Okay, now starting with kernel mode, and from the previous lecture, we have left with we have completed user mode. Now we'll continue with our kernel mode, right? Uh, in Windows NT, kernel mode has full access to hardware and system resources of the computer and runs code in protected memory space area. It also controls access to our scheduling, CPU scheduling, thread prioritization, or process prioritization, memory management, and and interaction with hardware. The kernel mode is also responsible to seize user mode services and applications from accessing critical areas of OS, which of course they should not have access to. Okay, and okay, that's for kernel mode. Now going towards some subsystems or executive services. Executive services make up the low level kernel. It is a low level kernel mode portion because it is much nearer to hardware, that's why. And it deals with IO management, security, process management, and all these subsystem functionalities are packed. All these subsystem are these are called executive services. We'll see every services one by one. Object manager, configuration manager, IO manager, LPC, local procedure call, process structure, plug and play, PNP manager, power manager, and GDI, graphical display interface. Right, so we'll start with object manager. Object manager. What are objects? Actually, object manager is an executive subsystem. We have seen that all other executive subsystems, especially system calls, must pass through. It is one particular membrane of executive subsystem, which filters all other executive subsystems. All other executive subsystems must pass through this particular object manager, because this is the one which is responsible for resource management infrastructure services. It actually allocates resources, whether it is physical resources or such as file system or peripheral, or an input peripheral like hard disk and all that, or logical resource such as a particular file. Each particular object has a structure or object type that object manager should know, that object manager keeps track of. And objects are, what are objects? These are nothing but allocation of resources to any particular program, whether it be physical resources or logical resources. Any particular program may have some set of any particular process. When it is defined, it has one object handler. Object handler is just key to identify the object name, particular object name, key or object name. We also call it an optional name, which essentially identifies that particular object. Process also stores type of object, what type of object is. We'll see the types of executive objects. provided by Windows NT. These are process also itself is a resource, a collection of executable threads with virtual address and control information, right? Thread itself can be called an entity containing code in execution inside a process, right? Thread is the one which actually get executed. Now job is nothing but a collection of processes. File, an OPAL file or an IO file. Access tokens to permit access rights for an object. This itself is an object which allows or grants access to another objects. And semaphore in mutex, which are essential objects for critical section operations. And key, registry key, Windows registry for all different programs which use Windows registries, right? So that's all for Object Manager. This now moving towards second one. Which one is this? Configuration Manager. Configuration Manager is simple. It actually implements Windows registry. It's simple. You type one Windows R, and that run window you type regedit, Windows plus R and regedit. This command will open all the keys, all the registry file in which a low level information of OS specific programs or few user programs. A registry file consists of low level information. For example, what is that? A program, when it is installed, a new subkey, when any particular program is installed, let us consider a user program, it is installed, it creates a new subkey containing settings such as programs, location, version, and how to start the program. These all are added to Windows registry in particular key for the program name. Okay, that's it for Configuration Manager. Object Manager is also done. Now we'll look for IO Manager. Okay. Right. IO Manager is nothing. It allows devices to communicate. It allows our IO devices to communicate with user mode subsystems. You have seen user mode subsystems, environment subsystems, and these integral subsystems. IO Manager allows. Suppose we have one IO devices. This IO Manager allows all those devices to communicate with our user mode subsystems. Those are integral as well as environment systems also, right? And it basically translates user mode read and write commands, R and W commands, into IRP commands. IRP is nothing in IO request packets. commands and passes it to device driver. Right. It also accepts file IO requests, file system IO requests, and translate them into device specific calls. Which can be incorporated into low level device drivers to directly manipulate hardware, either read input or write output, or whatever you need. So yeah, that's for IO manager. Now next one is LPC, local procedure call. It actually allows device to communicate with this particular LPC, it provides IPC ports. What is IPC? Inter-process communication. It provides inter-process communication ports, and these ports are used by user mode subsystems to communicate with their clients, to communicate with application clients. These are IPC calls. Right now, and yeah, that's all. This one is the basic functionality for LPC. It's only used for communications. We also have seen that in microkernel architecture that the few functionalities in user space, they actually make IPC calls to kernel, and there are servers over here in microkernel architecture. There are servers over here, and these servers actually they process the requests from this user mode applications, and then they pass on. This is simple. They pass on their requests, whatever the system caller made. It gets access to those functionalities via kernel, and this can be done by message passing via IPC calls. Message passing via IPC calls. Right now, next one is memory manager. Next one is process structure. Process structure